All right, welcome to section 4.2, polynomial inequalities. All right, so the first one we want to talk about is solving this algebraically. You do know how to do this. You just want to think about it. When I'm telling you to solve algebraically, I mean to solve for x-intercepts. It's the best way to help you all to do that. And so we just set each of those equal to 0. So we set each of these factors equal to 0. We don't care about the exponent right there, except for the first one's one we write. So this is just x equals 0, x equals 2, x equals -3. So now we're done. Solved for that. So we don't have to write them as x-intercepts, but we're solving them. That helps you to understand. That's what you're doing. So graphically, though, we have intercepts. So these intercepts would be, we've already solved for them. So our first intercept for this one would be 0, 0. We have a 2, 0, and then we have a -3, 0. Okay, and then we want to look at what the multiplicity of each. So at 0, 0, this multiplicity is a 2, so it bounces. At this one, this first one, it's from this 3 up here. So this is a multiplicity of 3, and so it twists. And then this is a multiplicity of 1, and so it just goes straight through. So if I just draw my graph really quick over here, I'm going to just plot my zeros. I have 1, 2, 3, 1, 2. Let's just go up on this way. So I have one at 0, 0. I have a value at -3, 0, and I have a value at 2, 0. Okay. I know that this graph is 2, 3, 4, 5. It's a degree of 2, 3, 4, 5, 6. It is a positive, so the end behavior is up, up. So when I do at -3, 0, I have to come through here. I'm going to just come straight through. Then go up to the 0 and then bounce it. That's a terrible graph. Try that again. So come down here, bounce, and then at this one it's going to twist. Okay, so again I have zeros. I'm going to just go over this one right here so you can see my zeros. Okay, and we'll use that in a second. All right, so that's graphing. Okay, so now let's turn it to an inequality. So let's let x squared, x minus 2 cubed, times x plus 3 less than or equal to 0, okay? And so for what intervals of x is the function less than or equal to 0? So we're asking, where is the graph? Below 0. Okay, and I want you to think of the x-axis, because if you think about this, when I'm talking about this graph and I'm looking at what's below the x-axis, or what graph is below 0, it's asking you what is the function itself less than or equal to 0. Well, that's below the x-axis. And remember, this is your x-axis. And that is where y equals 0, okay? That's your x-axis, or is when y equals 0, all those y values there are 0. So where is the graph below 0 on this graph, okay? All right, and where is it equal to 0? Because of this line right here, it's going to be both, okay? So now we want intervals of x. So these are x values that we're looking for. Think of domain. X value is a domain because we just have the x-axis we're looking at. So let's go see what that's at. So if we look at this, and what I'm going to do is I'm going to just go over here at this graph. Sorry, I'm moving all over. And I'm just going to kind of shade in or what's happening. So even in 2, you also can think of what's below. What is below? This is all below, right? Okay. This is all below the x-axis. All right. Okay. And then what I want to look is the x values. Now the thing is that because it's equal to, I made these very prominent. I want to make sure that they notice that these are big, red ones. So that I know that's where my zeros are at. So everything here is underneath here is less than 0. I also will do, you'll see answer keys like this where it's all showing where it's all in. But this right here is telling me where I have these red intersections, or x-intercepts, excuse me, is that's where they're equal to. It's a closed circle there. Okay, so we write the interval. The farthest number to the left is -3, and it's included. All the way, if you keep going, notice all these values in here, including 0, and including 2, must be included. So here's your interval. Now the next one asks the question, what if the inequality was changed to a less than 0? Okay, so I'm going to just go to this graph. It's less than 0. That means we do not get to include those x values, or the values on the x-axis, because it's not equal to. So I'm going to change these to open circles. They're green open circles, being not included. Okay, so those are not included, but everything else is still below. All right, so the question here is, where is the graph? Below x-axis, but not equal to, not equal to, okay? Can't include. The x-intercepts. Okay, so what I want to do is I'll look at it carefully though, okay? So I'm going to make sure that I'm starting here at still this value right here is still going to start there, so that's going to be a parentheses -3. Don't get to include it. So we go up to 0, but we're not going to include 0, so we have to stop at 0. And then we have to start up with 0, but put a union between, a U between, and then we're going from 0 to 2. And then there's your interval. And see the difference between the two, when the x values are included, the x-intercepts are included, and when they're not. All right, number 4. Okay, so the inequalities below, give the answers in interval notation. So the first thing you want to do is find the zeros as well as the multiplicity, because you're going to have to graph them, okay? I highly recommend you graph them every time so you can see what the graph is doing. So if I solve for my zeros, I get x equals 4 for this one, x equals 1, and x equals -3. This has a multiplicity of 1, a multiplicity of 1, and a multiplicity of 3. So that means straight through here, but this has a twist. Okay, so we're going to draw the graph, the number line. Now, don't worry about drawing the whole x and y coordinate. Just draw the x-axis only, like this is just x, and then just paste these out. They don't have to be perfectly slant. You just have to put them together, okay? So I have a -3, I have a 1, and then I have a 4, okay? And so I know I have these. Now this isn't just greater than, so all of these have open circles. Okay, so when I draw my graph, it is 3, 4, 5. This is odd. Degree is 5. So it's odd, and it's a positive leading coefficient, so the end behavior is down, up. Okay, so at -3, I'm going to twist. I'm going to come, I'm just going to go up here. So I'm going to twist, I'm going to come up here, up here and twist. Okay, at 1, I'm going to go straight through, and here it's straight through. And if you need to, I'm probably going to use a different color for these circles. These are open circles at the zeros. This is a 1, -3, and 4. Okay, so start from the left. Well, first let's determine I am greater than this graph. So all the values that are greater, I mean, some of y'all I noticed to use highlighter, which is fine. I just do the parts of the graph that I'm worried about. Greater is this here and here. Okay, and so I'm going to start with the left interval. I'm going to be -3 all the way up to a 1 union 4 to positive infinity. All right, our last example. So the first thing I want to look at here is I'm going to notice that I have 4 terms, so in order to factor to find the zeros, I have to factor by grouping, okay? So I'm going to pause you factor by grouping, and we'll come back to it. Okay, so I just kind of did this first part. I factored by grouping. I looked at this first one, I pulled out a 4, so this is kind of my hint, so I want that over there. That is the same thing. I can rewrite it, but they're both x plus 5. Now what I have in common is the x plus 5, so pull out that GCF, and we'll left over is a 4 minus x squared. You do not have to change the 4 minus x squared if you don't want to, so I'm not going to because I want to make sure you understand it's still going to give you the same answer. That's still a difference of squares though, so I still have to factor it. So this is 2 minus x, and then we have a 2 plus x. Okay, and then set each of them equal to 0 to find your zeros. So x plus 5 equals 0. So x equals a -5. So x equals a positive 2 here, and x equals a -2. Okay, so those are zeros. So let's plot those on a number line. Again, you don't have to do a y-axis part. You just need the x-axis. And so I have at a -5, it's going to be my first value, then -2, then 2. Spread it out maybe just a little bit, but it doesn't really matter. When I look at this first one, all of these have a multiplicity of 1. My degree is 3, and you can look at the very beginning, and I want to go back up to that and look at that, because here's my degree. I don't care about this right here. Here's my degree of 3. My leading coefficient is a -1. You don't want to do it from here because it makes sense. Go back here and find out what your end behavior will be. Your end behavior will be, since it's odd and it's negative, it's going to be up, down. Okay? So again, looking at this right here helped me with that end behavior stuff. So, but because it's less than 0, I have open circles and all those, but I'm just going to draw those with a different color, but I'm just going to go and I will do, so at -5, it's going to go straight through, so it means it has to come down this way. Okay, come straight through, come up, and then straight through. And for myself, I'm just going to put open circles at these because they're not included, and what is less than to me is below and below. Okay. So starting from the left, I have -5 to -2, those are parentheses, union, then 2 to infinity. It's not positive infinity because this is what the x is doing, not the y, to positive infinity. Okay, all right.